So now this video, we're focused on voltage, and I'm added a new page to my website devoted to voltage, and this will be the first video on there. So voltage is basically the push on electrical charges, and current is basically the number of electrical charges being moved in coulombs. So there's a lot more math to it. The main takeaway is voltage ultimately leads to current. So we have here a 100 ohm resistor on the board. So it has an electrical property of, for every volt across it, it's going to let about 10 milliamps of current go through it. And for some reason this power supply does not really like sitting at 1 volt. So you see the number kind of bouncing around. Now, a lot of current's going to flow through this resistor pretty quickly as we raise voltage, and it will get really hot. So we're only going to go up 1 more volt right now, maybe another volt. So there you can see 2 volts. We got about 20 milliamps of current. I limited this to 20 milliamps for an output, and I will change that limit for the next test. We'll go up to 3 volts, and that's going to start getting the resistor kind of hot, but there you go, not terribly hot. There you can see about 3 volts across it. We got about 30 milliamps. A milliamp is 1/1000th of an amp. So if we had a 1 there, it would take 1,000 of them to equal an amp. So milliamp is 1/1000th of an amp. So there's a direct relationship between the voltage across the resistor and the current flowing through it. So now I also have a 1 kilo ohm resistor. Makes the math easy, and 1K stands for 1,000. And so we'll pluck, again, that's pretty warm. The 1 kilo ohm resistor with 3 volts across it. Right there you can see it's actually about 3 milliamps of current. This isn't exact, but it's not spot on. A multimeter would be better, but this is good for getting an approximation. And then 220 ohms is a little more than twice the resistance of a 100 ohm resistor. So let's make the math easy and go down to 2. There you can see we got about 10 milliamps of current going through, a little less because it's a little more than 200, whereas if we use half the resistance right there, you can see we got twice the current. So again, these aren't exact values. They don't have to be exact with electronics. Approximation is good enough. So I'm going to put this here. We're going to look at the behavior of LEDs with voltage coming up. We really need a resistor. If you keep the voltage right, you can get away without a resistor, but you got to be pretty exact. It's better to have a resistor whenever you use an LED. So we'll look at voltages and LEDs. Let's get this back to 1 volt before we do that. So now, LED stands for light emitting diode. And what light emitting diode means is that when you forward bias it, so the long lead, the anode, we're going to put to the resistor. The short lead, the cathode, we're going to go down 1 row. I don't know how that's going to look, so I'll zoom in so you can see a little bit better. Short lead, the cathode's going down 1 row to that jumper, and I think it's not always making a connection in this area. So we may have some problems. But in any case, we're going to quickly raise the voltage to 3 volts. There you can see it lights up when we put it in that direction. Now if we reverse bias it, if we put it backwards, so now the long lead, the anode, is going to the negative rail there. The short lead, the cathode, is going to this resistor. Now it's going to block a lot more voltage, and it went to 0.3. But at some point it will start conducting, but it's blocking about 5 volts. And again, we may see once in a while they don't light up on these rows because they're kind of worn right now. But actually I don't want that at 5 volts. There we go. Let's go back to 3. Now I have it forward biased. The LED's on. So let's go back to 1 volt. Now we have it forward biased. There is no current flow right now. As I said before, the meter doesn't really like staying at 1 volt. It changes the display for some reason. But we got this dark because it's not going to produce much light at first. but we're going to slowly raise the voltage, and it kind of looks like it might be on. That's reflection from the light, so I'm going to shade it. But you're going to see somewhere around 1.5 volts, we're going to start getting a slight glow. So there we go, 1.6 volt, a slight glow. And 1.7, you can see rapidly a lot more, well, it's getting brighter. So it's still probably less than a milliamp. This isn't exact, as I said before. But now we got 1 milliamp, 2, and you can see now it's quickly rising the amount of current. That's because the LED is blocking a certain voltage, and the rest of the voltage is going across the resistor. So we saw before 1 volt across the resistor gave us 10 milliamps of current. That lets us know that there's about 2.2 volts across the LED. Again, these numbers are not exact, they're approximations, but approximations are more than good enough for basic electronics. So now another thing we can do, we already looked at if we have 10 times the resistance, the LED is blocking a certain amount of voltage, it's letting the rest go to the resistor. So probably about 1 volt right now. And actually the LED blocks a little bit more voltage as current goes up. And so this is 1 kilo ohm resistor, 10 times the resistance. I'll turn the power on. For one thing, I'm having a little bit of a hard time seeing where it's going. There we go. We're going to the positive rail there. And now you can see with that 3.2 volts, it's not even showing a current. And it'll probably show 1 really quickly now. 1 milliamp of current. And so in any case, multimeter would be more accurate. But there you can see we have to raise the voltage a lot more to get a higher current. So the LED is blocking a certain amount of voltage, and the rest is going across the resistor. That's the main takeaway. So you can use a higher value resistor to limit current more, and lower current will mean less heat for the same voltage. So let's turn the light back on. Now, we looked at the red LED, and there we go. With 3.2 volts, we got 10 milliamps of current. The green LED blocks more voltage. So I'm going to pluck the red LED and forward bias again, long lead the anode to the positive side, connected to the resistor, short lead the cathode, connected to the negative rail. There you can see we have less current. The green LED is brighter though. That's one interesting thing about the green LEDs, and the blue LEDs too. They are just naturally brighter than the red ones, at least with these particular indicator LEDs. So we're already probably less than 1 milliamp of current. But the main takeaway is when we start getting a faint glow, we got a little current there, there we go. Below 2 volts now, we're not even getting a faint glow. So we got the faint glow there, and it's steadily going up. So less than 1 milliamp until right before it says, or about right when it says 1 milliamp, right there. So it's blocking really probably about 2.5 volts at a minimum. There's a small trickle coming in, but so it glows a fair amount even with the small trickle. But in any case, it really blocks. Let's get up to 10 milliamps again. I believe we needed 3.2 volts with the red LED for 10 milliamps. So that means there's 1 volt across the resistor. Now we need 4.2. So we need quite a bit more voltage to get 10 milliamps of current through the green LED with a 100 ohm resistor. So this is why voltage is important. And as you can see here, if you have a power supply where you can adjust the voltage and everything, it makes things easier. Let's also pluck the 100 ohm resistor and replace it with a 1 kilo ohm. So it blocks a certain amount of voltage, and again, with the 1 kilo ohm resistor, that's probably close to 1 milliamp of current, but the meter just isn't picking it up. So same basic principles. We got the voltage of the supply and the drop of the LED. After that, the resistor sets the current, and so the voltage across the resistor will set the current. That is the main takeaway. It's voltage divided by resistance to get the current. You just got to remember it's the power supply voltage minus the LED drop. If it's just an LED, that's the first circuit most people learn, and then the rest of the voltage goes across the resistor. So I wrote this out a lot more. Maybe I'll add diagrams in the future to my new webpage on voltage, but that is the basic principles right there. That is why voltage is important.